and we follow up with the panel. So I would like to have Michele maybe introduce the panel and the speakers himself, but just one word. So Michele is a research assistant professor here at the Institute of the Wireless Internet of Things at Northeastern University. And he works here since a couple of years. Before that, he did the PhD at the University of Padua in Italy. And his research interests include open and programmable wireless systems, testbeds, and in general also open source software for networking. So please welcome Michele.
Thanks, Robert. Good morning, everyone. So if the panelists want to join on stage, please come, then I'll introduce each of you. No, what to sit, wherever you like. Okay, perfect. I have all 6 of them. So this panel is a panel on the conjunction between ORAN, testing, and open source software. So I want this to be a panel where we interact with you, you interact with the panelists. So I want a very high level of interaction. It's also what we have to do before lunch. So let's get through this and let's get to lunch. Here are my 6 panelists. David is the Vice President of Wireless Technology at Cable Labs. And he directs research and development of wireless technology for secure delivery of high-speed data, video, and voice for next-generation networks. Kalian has over 25 years of experience in the industry. He's with Keysight as a Vice President and General Manager of the 5G Edge to Core Group. Ali, you've just seen a talk from Ali, so needs no reintroduction. He's with the Advanced Technology Group at Ericsson. Ian has been in the wireless field for more than 20 years and is now the Director of RF and Wireless Architecture in the CTO office at Viavi. Raghu is an experienced technology strategist and is currently an AMD Fellow in the Adaptive Embedded Group at AMD. And Hongwei is a Professor of Computer Engineering and the Director of the Center for Wireless Communities and Innovation at Iowa State University, and also the PI for the ARA testbed, also headquartered at Iowa State University. So just a very quick introduction. These are probably some of the best people you can have on the stage to discuss testing in ORAN. I'll start with some questions that I prepared for them, but while I start for this, I want you to think about what are your questions. So when you are up at night, you cannot sleep and you think about testing in ORAN and what are the problems with testing in ORAN. So what would you like to know? What would you like to ask the panelists, right? Okay, so I'll start first with a question to Ian and Kalian. You have a unique perspective on basically the testing ecosystem. Where do you think this is going? What are the main challenges ahead, specifically related to ORAN and open source? Maybe Kalian, if you want to start, then we go with Ian.
Thank you. Can you hear me?
Yep.
Good. Thank you. And again, great to be part of this panel here. So to answer this first question, Open RAN requires even more testing to be done. First, it's obvious because you've now opened up the interfaces. What used to be a radio plus the base station altogether now is now getting split into the ORU, ODU, etc. But it forces many more challenges, or it puts many more challenges in front of us. One is about the compliancy. Are you really meeting the spec? The specs are still being determined, and in some cases, the spec is there, the compliance is there, but are you ready for deployment? So there are some challenges beyond what is written in the specs that we have to deal with when you put multiple pieces together.
Should we write them in the specs?
Sorry?
Should we add in the specs what is missing? Or is something that...
It's just a natural evolution when you put multiple things together. It's like standardization takes time, as we all know, and there's going to be some optional things. There's going to be some interpretation of parameters that we have seen. I'll give you an example. We were in the 5G challenge, and there were different vendors that have never collaborated together, that were put together to make something happen within a short time frame of 3 to 4 weeks. when you do that, there is going to be misinterpretation or a different interpretation, I should say, of specifications of the parameters and so on. And these are all fixable things, but you can't get there without really validation and testing. So when you really break a big monolith into multiple pieces, you're going to definitely see those kind of challenges come in front of you. Again, nothing that is so special about ORAN, but it's just a natural evolution process when you're bringing in multiple pieces together. Just because you're compliant doesn't mean you can interoperate. So that's where the interoperability comes in. And these are the basic foundation building blocks, as I call it. And now you have to take these building blocks and really get it deployment ready, where you're ready to deploy it in brownfield or greenfield operator networks. And that's definitely the next level of challenge, because that requires multiple things. You're looking at performance, you're looking at how fast you can deploy, can you interoperate and work with existing networks? What about 4G? When you want to do handoffs, there's just a lot of other things that need to come into the puzzle there. And of course, the resiliency, reliability, stability, all of these come into play. So without testing these, you definitely aren't going to go anywhere in ORAN in terms of getting it to the common, people out there. So that will be my take.
Thank you. Yeah.
Yeah. So I don't know what else to say, Kalyan. So, but so maybe a couple of thoughts. So some of you may know I'm also co-chair of the Test Integration Focus Group in ORAN Alliance. In terms of the future, right? I mean, if you think about it, the industry has been around for maybe 4 decades. It started with a lot of vendors. This is consolidated into maybe 5 major vendors. And we are testing all of them today. With ORAN Alliance, it's kind of turning that on its head, right? You're going to get a lot more vendors, maybe smaller vendors. Now you've got open source, hardware and software disaggregation. So clearly, with more interfaces, with more smaller vendors, there's going to need to be, I would say, a lot of learning in the industry, and a lot of making it hardened, right? Things like, for example, experts like Ericsson, the incumbents, right? We need to be able to replicate the performance, the security, the reliability of those networks. Otherwise, operators will not deploy it, right? Just to be honest, right? Like, it has to be at that scale. And so how do we get there? It's not going to happen overnight, just to be honest. And now the problem is also with the operators themselves, right? With the consolidation in the industry, operators have really relied a lot on these vendors. So a lot of the, let's call it, the skills needed to actually integrate these networks have really been transferred from operators to a lot of these vendors. So now there's a lot smaller vendors coming in. We need to kind of bring that back. And that's really what I see is kind of one of the roles of, let's say, the Open Test Integration Centers, the OTICs in ORAN, is to be able to extract, let's say, the common pieces of testing, and that way operators can rely on these OTICs, right? And not need to replicate those tests in their own labs. That's really, because right now, who are the biggest system integrators, right? It's actually the incumbent vendors, right? They do a lot of that integration today. And so I think that's a big challenge for the industry, for ORAN, is to say, you know what, we are as secure, as reliable, as performant, and a lot of what we do in the incumbent networks today, right, in terms of testing their networks, we want to be able to do that in multi-vendor interoperable networks. And I think that is not a trivial challenge. It will take time, but I think we will get there.
Thanks, Ian. I gave you the hardest job, being the second one for the same question, but
I don't think of ourselves as second to Keysight.
Yeah,
in order of these questions.
Yeah, one thing maybe that was missing is the private 5G that is also coming up. That's also an area where you probably need a lot of testing compared to other systems, but operator-led networks, basically. So, David, the next question is for you. You had a kind of a unique experience among the panelists, because at Cable Labs you hosted the 5G challenge from NTIA. So how did you see that evolving over the years? And again, also for you, what are the challenges that you've seen the competitors facing, and what is still unresolved, let's say, even after this year batch?
Yeah, thanks. First, thanks very much for allowing me to participate here. I think it's a great group. I'm going to add on to what Kalyan and Ian said a second ago already. So I'm going to say the quiet part out loud. I spent 25 years working at Nokia doing systems integration, and the work we're doing with the ORAN system and doing that integration is just putting it out there for the world to see. It took a year within Nokia to get new systems and a new technology lined up, even if it's within the same company, to bring them all together and do that system integration and get that alignment. It was still hard. It still took a long time. You know, you don't talk about that because it just looks like, oh, it's from Nokia or it's from Ericsson and it's all ready to go. It's system integrated. Well, all the work that it took to get there, we're just now doing out in the open. So none of this is new. The interfaces have always been there, to your point earlier. So yeah, the 5G challenge, it was a great opportunity for us to partner with NTIA. For those who don't know about it, DoD funded this activity to get money rolling in the space as fast as possible because they had the money to do that. It was a 2-year activity. We spent the last 3 years working with them, getting it up and running. The first year, it was a challenge. I'll say that. We had very few vendors who participated. We got them together. We did the testing. We did it in a very unique way. We tried to do identify conformance and compatibility with the interface to a test vendor lineup. And then once we said, yes, you conform, you're good, we put 2 vendors together. And we actually saw great results. Instead of seeing 6 to 9 months worth of integration testing because you had to go all through the challenges and the problems of the interface, we actually got it down to getting it up and running within 5 weeks. So that was a tremendous activity. The second year, I would say, great progress with the vendor community. We had a lot more vendors wanting to participate. We had a lot more vendors in the lab. We were working with 10 different software functional vendors, not including even the stack vendors or the hardware vendors. And in that period of time, like Ian was saying just a second ago, it was a very short period of time, but we were able to actually get everybody through what we call our stage 4 testing, which brought the multi-vendor environment together end to end. And we actually got to performance testing. We got to stability testing. We got to mobility testing over both the RAN and core mobility. So actually great achievement just within the year and then the second year that we did. So you asked about a couple of challenges. So I'll throw out a couple of challenges that we're still seeing. The first one is that there's a lack of common profiles. So right now, if you go and put all the different options, questions, do you want to do A, B, or C, et cetera, of the ORAN interfaces, for example, the front haul interface, that spreadsheet would be 1,000 lines long. And how many times are you going to get 2 engineers in a room that select all the same 1,000 things the same? I mean, never. It's not going to happen. So getting that profile defined, getting that profile accepted, getting everybody to align on a certain profile, and that doesn't mean there has to be only one profile, but choosing what those profiles are and testing that would be huge for the industry to help drive it forward a little bit. The second one is that we truly aren't disaggregated when it comes to hardware software. We invited vendors to provide software only onto a stack that existed, and basically it was like, no, I want to bring my own hardware. So it's kind of like the old Ford thing. You can have any car you want as long as it's black. Well, you can use any hardware you want as long as it's the one that I chose already and did my integration with. So that's still a challenge. We have to disaggregate those two. And then the last one is money. As was just mentioned a minute ago, the operators aren't putting a bunch of money out and doing a lot of deployments with this yet. Where do we get the money to bring the vendors together to go off and do this? Most vendors are new and they don't have the few $1 million to go out for the lab and get the test equipment and work with other vendors to do it all together. We have to do it as an ecosystem, and we have to get the money somewhere to make that happen.
Thank you. Yeah, Ali, please.
Yeah, just to add to this, for a while I was working very close to our infrastructure development group, and by their estimate, they spend about 1/3 of their time doing interoperability. So it is extremely expensive. They do, I mean, at some point they have to work with other companies. I mean, even in the old setup without the disaggregation and so on. They have to work with phone vendors. They have to work with other infrastructure vendors. And it's also a backdoor way to choose features. You know, when you have 1,000 parameters, they end up picking the same ones, right? So you also see some concentration of features due to the infinite complexity of trying to do interoperability.
Thanks. Yeah. So you all four mentioned interoperability, testing, and system integration. So where does testing and integration stops and the system integration actually start?
Yeah, that's a great question. I don't think there's a hard line where one starts and one stops, because you can get all the way through interoperability and then go into system integration. They have to go back to interoperability to figure things out and to do the troubleshooting that was there. I'll give you an example. So back in the 2G days, I was doing system integration on the core to RAN interface, the was that the ABIS interface, I think it was called at the time, and it was crazy. No way that Nokia's core could plug into Ericsson's RAN or vice versa. Oh my God, the world's coming to an end. But over time, we got to the point that, well, that's just normal, and it happens all the time, and it works great. So we're again in that stage right now for just further down the line, new interfaces, and it takes a lot of work from the vendors to work together and to make it happen.
If I can just add to that, one of the things we see is the benefit of the CI/CD that many vendors are now choosing is exactly for this reason, and it's even more pronounced in O-RAN world, because now you have many components. We just talked about what if all of the things come from Ericsson, or you're partnering with a couple of other people. You're talking about many software components, many hardware components, all living together. Give you an example. In a brownfield operator, we were really looking at least 2-3 changes a week coming from somebody. It could be a firmware on the radio vendor. It could be the infrastructure provided by somebody like a Red Hat Telco Cloud. It could be just anything, right? It could be the DU. It could be the layer 2 stack. So a lot of software pieces. And as we know internally over the years, it's the load lineup as to what you need. In combination, in concert, when they all work together, that's a challenge. So the whole CI/CD pipeline is created in such a fashion that the independent testing never stops. You're going to have the subsystem level testing going on while you promote some of those components as they work in concert with other things into, let's say, the production test line. But very quickly, something could be changed and you could bring just that component. And that's the beauty of the CI/CD. So that we have seen it in action. And I think it's very much required in a complex world like O-RAN, where you're bringing in multiple vendors, both hardware and software. And like I said, upgrades are happening a couple of times a week. So it's massive and very different from the traditional world.
Now, I want to take a step back here and make a complex problem even more complex. So far we've seen, when O-RAN consortium actually started, the first goal was to break up the front haul. Like everybody's goal was to make sure many different radios work with many different DUs and so on. But over these years, in the last 2 years, actually I've seen a picture emerge, which is very heartening. It's not just the front haul. We've seen a whole architecture defined. And today, when you talk of platforms, we've seen something, in terms of multiple server vendors. And O-RAN basically means, at this point, open hardware, open platforms, which means it's no longer proprietary hardware, but hardware from the likes of Dell and HPE and Lenovo and Supermicro and so on, accelerator cards from multiple different companies, CPUs based on multiple different companies, AMD, Intel, ARM-based CPUs, and so on. Now, similarly, in the software stack, we've seen Red Hat, VMware, Wind River. We've seen open source systems from basically Kubernetes based, and there is the ability to stitch a platform together with two of any of these guys at every stage: the platform stage, the servers, the accelerators, the software platform, the vRAN software vendors. So all the way up, we can pick and choose 2 or 3 of any of these guys, which in fact, I guess, was the vision of the operators when they conceived O-RAN, to have multiple platform vendors, multiple sources, which also goes to improving supply chain security in a way, right? Today, we've discussed testing one chain of the stack and how complex that is. Now, this is where what happens when we have this, ultimate goal of any platform working with anything else. How complex can that task be? And what is it that we can do to make that life simpler? So the true vision of ORAN is actually, right? So in a way, at least in my opinion, I think we've come a long way in that sense that at least now we see the makings of a multi-vendor platform and a multi-vendor system come through. But then the big job here is to simplify many of the interfaces we put together. If you just look at the front hall, it's still evolving. We've seen, you said 1,000 lines, David. I mean, that those 1,000 lines will grow to 3,000 lines now when the new version of the front hall standard kicks in. So there's no end to this, right? So at some point, we need to start shrinking some of these tests and lining up some of the interfaces or the testing, the options in each of these platforms, so we can get to test the real ones. The multi-flavored, multi-vendor system that every operator wants to deploy. If they pick 2 of each one of these, there are already 24 to 30 different ways in which the combinations can materialize. So yeah, how would we test that?
Basically defining some profiles that David was saying, or the blueprint idea that Tracy was also bringing up earlier. You're saying focusing the test on this, right? Any other thoughts on?
Far more complex than what we are looking at right now. I guess that was the point.
So basically, end-to-end testing is more complex than just stitching 2 things together. Any other thoughts on this?
And that's not even, sorry, and that's not even including when you start thinking about the SMO and the RIC.
Yeah.
So once you get beyond the straight line, core to CU to DU to RU, et cetera, you have to go one level above that to the application layer for the RIC.
Do we have any more microphones? Because there's one question over there, so I'll just bring this here and then we're going back over there.
Actually, thank you for the nice discussion here. Interestingly, I worked not just for one ORAN company, but 3 ORAN companies, 3. And at one of the ORAN companies, we actually burned several $1 million with 2 architectures. For the FR2 system, we actually went with the 7-2A. And we came to know that the operators don't want it. That's dead. FR2 and 7-2A. Then for the FR1, massive MIMO, we went 7-2B. Now we actually have a new wrench in the system. That's a ULPI. God knows what it is. Because ORAN Alliance is not open about TDocs. The TDocs, the technical documents behind the work group 4, are not released to the public. Only the final specifications are released to the public. So that means that only by the end of this year or by early next year, we will know how good or how bad the spec is. There are several hundred researchers here. A lot of people are actually getting government money. If the TDocs are open to the people, all these researchers, all the graduate students can actually do a better job in figuring out whether ULPI is a good idea or a bad idea, whether 7-2B is a good idea or a bad idea. Because we burned millions and millions and millions. Because a 64 TRX massive MIMO radio is a nightmare to build. We built it. Nobody wanted it.
Yeah,
So
maybe I can.
Yeah,
And so just to add to that one, right?
Yeah.
So now you guys are asking, right? What is that's keeping us awake at night? Even in the morning, I got to drink 3 cups of coffee, right? So it's because now we look at 7-2B and now ULPI, and nobody knows what that is. Even if you know, you cannot talk about it because you are under NDA with the ORAN Alliance.
So, yeah.
So
yeah,
Maybe I can address that real quick, because actually, being in ORAN, that is actually not true. ORAN has about a year and a half ago, more or less, right, actually changed for everything technical within ORAN to be non-confidential. You're right, it's not as transparent as 3GPP where everything is immediately posted online. But it's actually not, you don't need NDAs. In fact, you could, if you have a buddy that works in an ORAN Alliance company, right? Just ask him for the documents, and he can share it with you. Maybe after lunch, maybe have to treat him for dinner or something, right? But it's actually not, it's not confidential, first of all. And so, I mean, in fact, I think it's in the pipeline to actually make it a lot more public. I think that is true. That it's not as public as 3GPP, but it's actually non-confidential. So ORAN members can share the documents with you, and I'll email the whole lot to you if you want after this panel. So.
Thank you. Thanks. I think Lincoln has another question.
Yeah. So back to the interop of the profiles that you mentioned. So there's other examples and other specifications that we can see where that's been done. And the danger there that I've seen happen is it then becomes operator A profile, operator B profile, operator C profile, or regional A, region B, region C. So do you have thoughts on how to prevent that chunk from happening so it doesn't become, to pick on Tracy's favorite profile?
Yeah, I think that is true. I mean, even today, right, and not everybody may know this, right? Working Group 4 actually has an interoperability test spec. We're actually the editors of that. And it's got a lot of profiles, right? Like, FDD, 4T, 4R, massive MIMO, et cetera, right? But those are actually came about through vendors and operators actually coming together and say, these are the main parameters we would like to have interoperability profiles around, right? So Working Group 5, which is more in the XN, F1 interfaces, there's similar profiles there. But yeah, there's this movement to kind of elevate that a little bit to have it more end-to-end. Like, what is the people call it blueprints, some people call it minimum viable profiles, etc. So I think the key here is to at the end of the day, for the most part, right, there are maybe urban macro networks, right? Like, apart from maybe Spectrum, as of course very regional, there's going to be the hypothesis is these canonical blueprints that if we extract them as a minimum viable profile, they are sufficient so that operators can have enough confidence on this, let's say, conglomerate of multi-vendors in this profile, tested extensively all the way to performance, load and stress, etc., that they don't need to repeat those exact same tests and say, you know what, I'm just going to test in addition to this these things that I really care about. But it takes the whole community to come together, right? All the operators, at least I know NTIA is actually working on US-based operators to kind of rally around what are those minimum viable profiles that can be, that actually, at the end of the day, they kind of look similar and really least common denominator type of exercise, right? What are those in an test?
One thing I'll say, the point you made is not actually a bad thing, for an operator to have a certain profile. And today operators have different spectrum in different places, so they deploy differently. So having different profiles in itself is not a bad thing. And since we are talking about testing here, in fact, from the get-go, when an end-to-end system was broken up and made a multi-user system, there is this thing with shared responsibility for testing, systems testing as well. So the question here is not so much that you should have different profiles for different pieces of the DU versus having different profiles for different operators, right? So minimizing the profile and making it consistent at each layer of the infrastructure is critical. That's important. So you should be able to test a particular vRAN stack on a particular server with a particular type of accelerator with a particular SMO. All of that needs to happen. And whether the operator picks one or the other or what type of profiles they set up, perhaps is up to them. So I think we need to understand, in all this, we are talking of one company testing the whole thing, but then there is also the shared responsibility of testing at different levels. And if when say, AT&T or Verizon deploys something, it's their responsibility also to test the end-to-end stack on the configurations they are going through. So the question here is, what would make it appropriate to enable such a test from different operators? What is it that we need to do to the profiles to minimize that level of testing? I guess that's the other thing that I wanted to impart.
Just to add to the points both of you made, I think it's we are getting to a crucial juncture now. I look at it as we are getting to game time, and you have the OTICs and other things that are providing you the certificates and badges. That's great, but there is a gap between that and operator readiness.
Yeah.
The MVP profiles will get you there. It's going to be focused, and it may miss some things, to your point, but you need that focus right now for it to get into deployment. Without that, it'll still be warm-ups, it'll be experimental stages, which has to continue, but there is also a thread that has to take it from, good, we have played all these things together, now let's pick a few things and take it all the way. If you don't do that, then you're still going to be in this whole science experiments, as I call it. So we need to graduate it. But without there needs to be thread on how we continue to experiment. That needs to continue as well.
So basically, I see some open what you're all saying. Things are improving compared to 2 years ago. You have a better multi-vendor ecosystem, but now we need the real jump toward deploying this.
Deployment, that's the key.
One way.
Yeah, probably. Just to add to the discussion, I think similar conversation actually have taken place in the industrial network settings. Even in the old world of wired industrial network, I think over the years, over the past decades, we have seen the convergence of kind of use case-driven kind of consolidation of different consortiums and profiles. I think probably we can take, there may be something we can learn from there. For example, we think about the profile, how to actually come up canonical use profiles. I think probably it's important to keep the end use case in mind. For example, there are different service categories and also scales of networks. I think as a way to kind of take a principled approach instead of being buried into too much into the details. Kind of have application in mind too.
Gotcha. Yeah.
Just to wrap up on this one, fully agree with what everybody else has said. I think it boils down to my third challenge that I mentioned early on in the question, and that's the money.
Yeah.
The operators do need to start putting in some dollars to invest in the ecosystem. Right now, they're not, and certainly we all understand why they're not. They've already deployed their 5G systems. Why would they change that for O-RAN today? They wouldn't. It doesn't make any sense. But there needs to be that investment, and around the world, a lot of governments are stepping up to do that because they see the need to seed the ecosystem as well. So NTIA is doing the WIF funding from the CHIPS Act. Government of Singapore is doing it. The government in the UK is doing it. Japan, all over the world, you see countries stepping up and saying, okay, I'm going to invest in this and invest in the technology ecosystem. So it is happening too. It'll just take some time.
Thanks. Any follow-up, any other question from the audience on this? Florian?
That's a great discussion we're having. I'm just missing a little bit the open source perspective here.
That was going to be my next question.
Okay. Shall I ask mine nevertheless?
Please go.
Yeah. So, well, it's an easy question. Maybe you can refine it after. But what does the open source change in the game? Does it make the life of testing and interoperability and everything easier, harder, or indifferent? And you treat it as a normal as any other vendor, really?
Did you read my questions in advance?
No, I didn't.
So maybe just to add, I think the open source, OAI, SRS, and a lot of open source, I think it really democratizes the ability for researchers to have access to a network, right? Think about the 3G days, right? Like how many people have a 3G base station in their lab that can actually play around with it, right? Probably very, very few. 4G is the same way. I think the ability for open source software to really impact research, I would say that's the number one, right? And I think we need to continue on that. We want to see it graduate to maybe more real networks, maybe start with private networks, bespoke networks, etc. But I think in that case, we really need to focus on performance and scale, right? And and everything else that comes with what's needed to actually for it to be deployed. And I think that's still a challenge, right? Just to be honest, right? And we want to see more of that. Truly, let's call it tested. Again, carrier grade. How do we get there? But yeah, I think that's the main challenge for the open source side is performance and scale, and of course, security.
I'll give you a much more concrete answer here, right? So yes, open source has a role to play, and testing is a critical part of it. Because when you put a whole system, end-to-end system together, there aren't that many things that a company like ours can use to test the whole stack. And we rely on OpenAirInterface. We rely on other open source systems to do that. And in fact, from our point of view, from AMD, I'll say, we want to provide platforms that are identical that we supply to the proprietary world as we would make available to the open source world, or to the general community. So giving such open platforms is one way for the open source community to have the same platform that every other larger company has to innovate, to build good systems on. And at the same time, here is one software stack. It may not be high performance, it may not have all the bells and whistles to deploy, but it's a functional full stack system. So you can place a call to a commercially available UE, a cell phone, right? So to the first level, there is a certain degree of functionality testing that is enabled with open source software. So we use all that. Although we cannot test everything we want to, there are many things we can test with open source systems.
Yeah, just to add, I think another aspect is not reinventing the wheel, right? So why is a startup that wants to get in this space, because we're trying to get more vendors into the ecosystem, why does that startup want to start it from ground zero and create the entire stack themselves and write their own software code, et cetera? We don't. We want to have to enter into the ecosystem. Boom, you jump up here, and now I'm just working on the functional software itself. So I think it plays a big role in helping drive the adoption and the acceleration of new vendors in the ecosystem.
And what do you think instead about, you mentioned performance, meaning that you had in mind open source run, right? But there's also other parts of the open source ecosystem that contribute to ORAN and in general BridgeBB, like SMO, RIC, Core. What do you think about testing in that space? And what are the challenges or the potential associated to those pieces of the stack?
Yeah, so we are already seeing some benefits with projects like Nephew, which has come a long way. And clearly there is more and more embracing of that. I mean, it's well known that open source has benefits in multiple areas so far, and this is nothing new. It will also have benefits here. I'll give you very specifics, trying to work with the 5G, free 5G core and interoperating with some of our components has been very valuable because we know that we can plug into the ecosystem in a certain way. Project Nephew is a good example of that. There's other things also that we are seeing OpenSRS and so far that is really beneficial. And we also look at how we can utilize that when we go further in places where we don't have to reinvent the wheel. There's no point doing that when there's a whole community of people pitching in and doing it. And as somebody pointed out, there is access that is very important when you are really expanding the ecosystem of people who can actually get into Open RAN. I think open source automatically comes into areas where it can help. Yes, there are going to be questions on, is it deployable in a real network? That's probably going to be some time because you have other aspects there, performance, stability, security, and so on. But for just validation purposes, especially in areas where you don't have to reinvent the wheel, I think it's very useful.
And just chiming in, I think I want to pick on OSC a little bit, right? I think at the end of the day, if you see where the OSC started, I mean, Viavi, we've kind of supported it from day one, right? The RIC testing from the start. And I think the open source community, if you think about it, like the performance and scale is really challenging on the user plane, right? Because that's always going to be it's called a big challenge. But aspects like management, aspects like the RIC, those are things I think that open source can really make a big difference because you capitalize again on the research community that's really trying to change the game in terms of intelligence in the network, et cetera. So I think there's definitely a lot of promise there to go all the way to deployment. And I'll just be kind of blunt, like on the user plane where performance and scale are truly needed, we're still a long way.
And just to add one more thing to the open source and the initiatives that it can help drive. As we all know, if you ask any operator in the world right now, the answer to the question, hey, how do you like 5G is, where's the money? They haven't made any money on their 5G network deployments. Every single operator will tell you that. I got a little bit more performance. I got 20% better speeds and feeds, but really there's no money that I can make on this. So the open source will help drive the application layer innovators to go off and say, hey, I could do this with this, but they have to have a network to play with. They have to have the interfaces to go and do things with, and having that open source software allows folks that can't afford the $5 million investments to go off and do this application development, allows them to get into the game and drive a operator money so that they can deploy applications that will make them money.
So basically show innovation in the open source domain and then build the product and
Correct.
sell it. I think there's a comment.
Yeah, just a quick question, coming back on what I think is possibly an inherent contradiction in some of the things that you guys are saying is we seem to be trying to tar all open source with the same brush here. And I think we need to consider different levels of ambition for different types, different open source initiatives. And in some, you talk, for instance, about making something available for open source. So, for instance, academic research and innovation, proof of concepts, entry level innovation. In my opinion, those types of open source projects should not be held to the same requirements as commercial grade open source projects. For instance, security, integration, scalability, they're really hard and they're really expensive. And if you were to put those same requirements on the entry level target audience that you're aiming for, you will completely stymie innovation there. If we were to consider, if you pardon the pun, a spectrum of expectation levels for open source, different levels of maturity, different levels of ambition for different open source projects, then you have some open source projects that aren't even attempting to be interoperable with other functions, because there you will see massive innovation. At the other end of the spectrum, you'll have open source functions that are being used in commercial deployments. And as such, it's more important that they are properly tested and secured and scalable and interoperability tested. So I think I would like to see maybe a comment on the, can we achieve different levels of ambition and still see the value of we can't do a hatchet job on some open source projects and say, oh, okay, that's not secure, we can just write that off. And yet ignore all of the potential for innovation that arises from that. Similarly, we see with, for instance, the picking of one or a small number of showcase type open source project at the detriment of others, just so that we can achieve these essentially non-functional requirements when we perhaps should be promoting more blue sky thinking and forget about interoperability testing and security and integrability and to achieve that first kickoff.
Yeah, even though you can, at some point, you need to transition that innovation in some components that need to be secure, interoperable, and deployable. Otherwise, the innovation just remains within
the different levels, different points in the curve. And I don't think that we can apply the same requirements at all points in that curve.
Oh, wait.
Yeah, I think you made some really good points. Right? I think as an academic, I definitely share some of the same sentiment you have. But in the meantime, I think, especially given that this is a crowd with many, actually both academia and industry, I think that's where, I guess, being academia, we want to see how we can probably make better contributions potentially and even have near-term impact. I think that's where some of the discussion would really come into play, like being able to run quality, even open source code in real-world settings, be able to have potential impact in the near term on wireless and also applications. I think as an aspiration, I think that's just something worth thinking about. Absolutely, I think.
I cannot agree with you more. And in a way, you so eloquently said what I was saying in different places, right? Like we're in, let's say something like OAI and SRS, right? Where it shines is really the research part. And then you have open source projects like, Kubernetes, Nepio. These are truly, enterprise scale, going to be deployed, and they should not be in the same vein, right? But I do feel that there's an ambition for a lot of these projects, including OAI, SRS, to also be deployed. And I was just in Milcom, and SRS was there, and they're talking about their stack being deployed in some networks that are more bespoke, right? Again, going back to private networks, there's going to be so many different types of networks now that can benefit from 5G technology, that I think there is a place to play for even the RAN part, the user plane part to in these. And but yeah, will a tier 1 operator truly deploy open source, RAN in their macro? I don't know. Maybe someday, but it's kind of right now. Yeah, we have to understand what is required of each of these projects and do the appropriate level of testing, so that again you're not sorely disappointed, right?
So maybe if I may just add one point there, I guess. We have seen like Linux, right, as an operating system, how much impact it has had in both industry and academia, and also how, as a production quality open source platform, it also empowered the academia to even make tangible impact. So part of the question will be, can we do something similar in the O-RAN or even open source 5G platform in general?
So I fully agree with you, but I don't think the point is being made about requirements, but it kind of goes back to a previous question I asked about just transparency, right? The person providing the open source platform, did they intend for it to be addressing scalability or performance issues? And, I know from our own experiences, understanding which interfaces they actually implement and whether they've been tested is really the point for people adopting open source for whatever your research purpose is. And that kind of gets back to the other question I really wanted to ask is, so what's the incentive model for open source? We've talked about the scale and the complexity of testing to get tested. Yeah. Right? How do we incentivize that so that these open source projects, are willing to test? And if you claim you implement 3 interfaces from the O-RAN Alliance, that you've gone through some level of testing, not as a requirement, but as a transparency issue to be able to claim that.
Yeah, I think to piggyback on what was already commented on, there is 2 types of things. One is the ones that are academically oriented, research oriented, which is finding its place. It is coming up in multiple places, which means as a virtue of that, you are verifying it, you're having to work with that, you're having to interoperate. And there is some value even from test companies' perspective to see some of these things come up because we use them as well, where we don't have to go and reinvent the wheel. So there is that testing happening. And then there is this commercial, or at least enterprise grade thinking that's going on. And there are some big sponsors there. These companies that are hosting Project Nepio, Google as an example, there's definitely a lot happening there where they're not just looking at it as let's give it free here and there. They are looking at how to monetize it, right? So that's a step in that direction. And there's a lot of other testing that's going on by these events that go on, by very specific milestones that they want to achieve. And again, another avenue for bringing multiple vendors in play along with open source components. So that's the distinction between what's happening there and what's happening, let's say, in a 5G challenge or somewhere else, where it's purely vendors, there's prize money and so on. But the Project Nefios and others that are going on really are bringing in a combination, and it's got to be a combination. It can be purely open source only community because you got to bring it in along with some other vendors because there's got to be a pull there. I think that's what is happening in those projects. And those projects have the good benefit of being verified first because you can't deploy it otherwise. And you got the muscle behind that as well, right? The muscle is being provided. Some big companies, they want to come in. They're also looking at entry points such as private networks for sure, where you can tune it and tweak it. But I think these are two separate avenues. So it's not purely, there's a research avenue where, again, like I said, we are validating it in a slightly different way. But I think the other Project Nephews and other consortiums that are out there are also bringing in open source in concert with other vendor implementations.
Ali?
Yeah, I mean, I think I want to disagree with the gentleman over there in the sense that if you want to do research and for your own reason you decided to use this complicated platform that represents, say, 5G or 6G or whatever the case may be, you can exhaust yourself trying to run it if it's not stable enough and runs properly enough. So even if you don't have the ambition for your own work to become part of a standard and be tested and be put through this whole machinery, you want the machinery that you are using to be good enough. So I don't know who is going to do that for you unless the quality is brought up.
And I think another perspective is a difference between open source and products is that open source in general has a community behind. So there's not one single person that provides an open source project. Potentially, if you want, you could contribute a feature you're interested in to the project. So at that point, it becomes more of a community question. What are the features that the community provides or is interested in providing rather than a single product or company effort?
If I could chime in, at the end of the day, it's about aligned incentives, right? Again, it's hard to go against the laws of economics, right? Like, I would cite the example of SRS RAN. I mean, I know this is an OAI conference. I'm sorry. It's a competition, I'm sure. But I mean, they're truly, they're being deployed in trial networks. Networks that are pointing to the sky. It's kind of more bespoke. And they talked about it again in Milcom, and they're testing the heck out of it. And at the same time, it's open source, right? And so they're incentivized because they are a commercial company, right? But still supporting the open source community because they believe in the spirit of open source. So I think there is a way for incentives to align, to actually put in the investment. And of course, we're supporting them in their testing, so we're happy. But at the end of the day, it's really, what are the incentives, right? Can we align those incentives so that there is motivation to make it more robust and more useful for a broader set of community?
Better?
Yes.
Yeah. So this is FireCell. They are deploying OAI, so I just wanted to mention that.
I want to talk to you guys. All right.
Right. And there is also All Be Smart over here. But one thing that I would like to say, I mean, people say lots of things about SRS, and that's it's great to have them there. But at the same time, SRS is a commercial company, right? And even the open source software that they put out is basically one version of their commercial stack. It's not coming out from an academic or a community initiative. So, speaking about SRS and OAI, I mean, even though both provide open source, they are not really comparable, right? One is a commercial source, the other one is a community source. So I wanted to emphasize that.
I may have ruffled some feathers here. So I did see SRS brought up by Tracy in her slides, so I thought it was fair game. But. Okay.
No, I just want to say that, just as AT&T and Verizon coexist harmoniously, OAI and SRS RAN will coexist harmoniously.
And Viavi and Keysight sitting right here, not punching each other in the face. So
I did have one more serious question. And this has puzzled me from the beginning. Why are test results treated like some deep, dark secret? What is the sensitivity there? We all know that.
I'm going to pass the mic to Erickson.
In fact, that's a good. I have a counter question to that.
Oh no.
Oh, absolutely. So in the past, we've seen companies like us. Every operator has their RFIs. We've seen dozens of RFIs, RFPs come through. My question is, why can't we have a few set of RFIs that we can all respond to. And it takes us so much time to respond to these things and to create data and to generate them and provide them. And then nothing happens. I mean, we've seen this over the last 3-4 years. It is true, test data can be shared, RFIs can be shared, and that's one way to minimize the effort on the ecosystem, in fact, which also goes to all of us investing money to provide these systems. So when money is scarce, effort also will go scarce, and that's what we are seeing now in the lull of this whole ORAN thing. There was the hype, and now the depression set in. But I guess in the next coming few years, we hope to see this thing come through and stabilize and get deployed. But the point is, there could be a lot of sharing, not just on the test results, but also on the RFIs and RFPs as a shared effort to get this thing to a stage where we can all minimize our efforts, repetitive effort, and get it to deployment.
Who should push for sharing? Vendors, operators, ORAN, OTICs?
When you look at the European operators, the big four have come together and they've created a certain common profile, if you will, right? And although they don't put out common RFIs and RFPs yet, there is some level of sharing. I again made this point there as well, that there could be a common RFI, RFP. Why do we have to respond to similar RFIs, similar traffic models for all of them? A few megahertz smaller. One person wants 10 megahertz, the other person wants 20 megahertz. Come on. Yeah. So some of these things could be standardized or unified and results shared. So effort on all of us is minimized and we can get quicker to a deployable system.
Yeah, I think each one is in a different state, right? You talked about the European operators. Very clearly, Vodafone is not in the same stage as others, although there is a lot of sharing of work, I would say. But if you look at Vodafone, they have definitely gone ahead. They have already done some open trials and they want to expand. In fact, they basically said the next deployment of 180,000 sites, 30% of that is going to be Open RAN. That's what they've publicly said. So there's definitely a lot of push and momentum, which this whole ecosystem needs from an Open RAN perspective that's provided by few operators. Doesn't mean an AT&T or Verizon are not doing it, but they also are looking at when is the next spectrum coming out or what is the right opportunity to go deploy Open RAN. If you take a look at greenfield operators like Dish, they lit 20,000 sites, all Open RAN. Lots of challenges faced, and and of course, you could also argue how many people are using those phones right now. But there is a network, and they have tried very hard to really pull in a lot of different people in the ecosystem. A lot of learnings there. All of us had to go through. I think there is also events like the 5G challenge where those results are shared, and there's a lot of vendors participating in that. To your point, I think, can we share the results of OTICs? There is, but there's also some sensitivity and I want to test my
results of tests. She asked the question.
Okay,
my question
sorry.
Was,
okay.
Why can't we share RFIs and RFPs?
Right.
Also?
So I'm looking at you, but I should be looking at you as well. But I think in general, I think there's no doubt we need to share more. But as far as where each operator is in their journey, it's different. It's not the same. What's there for Dish is different from AT&T, is different from Vodafone, and I think we see that because some are really pushing because they have an immediate event coming up where they would like to utilize Open RAN. And some others are looking at what is that event that will actually take me to Open RAN. I think this is really what we're facing. The thing I will conclude, at least this part, is the Open RAN was actually created by operators. Operators wanted it. That's why we are all here on Open RAN. So it was not something that vendors and other parts of the ecosystem decided we should have Open RAN. This was formed by the Operator Alliance, and I think I'm hopeful that it'll still come through, but each is in a different stage of when they want to deploy and how they want to deploy.
I think I want to clarify a little bit. There might be a misconception. I mean, at the end of the day, Open Test and Integration Centers, OTICs, right? Whenever any equipment goes through certification and badging, it's actually required that it is shared at least to all operator members, right? Because vendors is a bit sensitive, right? And so at least that part for operators within ORAN Alliance have access to all those test results. But I think the elephant in the room is more like, when you actually do performance testing, right? Vendors, our experience has been extremely sensitive on actually sharing performance numbers because again, other industries have done it like CPU benchmarking. That's pretty common, but for some reason, RAN vendors are very sensitive to doing that. I don't have a good answer on that. I mean, it would be great if we do that, and then we can even have, again, that's a role for open source as well, right? Let's say somebody who wants to do a benchmarking exercise can maybe start with SRS versus OAI, right? I don't want to ruffle the feathers again, but I mean, it starts there, and maybe the Open RAN, end-to-end system can go through that benchmarking, and maybe through that we incentivize the incumbents to also come in and go through that same benchmarking, because I think it will serve as a race to the top rather than a race to the bottom once numbers are shared, and it'll be good to kind of change that culture a little bit. Yeah.
Ali, then David, and then we have a question over here, and then I think time is kind of over.
So if we're attaching performance to cost, in the sense that I can have a better receiver that costs more, we can't just talk about the performance, right? Because like when Ericsson sells something to AT&T and Verizon and so on, it's a very complicated deal, and there's probably some requirements on performance, and then there's cost, and there's all kinds of things. And if we want to just isolate performance in the academic sense, then we would submit our best thing ever. If cost is no object, we can do wonderful, right? But then cost is an object, so you have limits on complexity and all kinds of things. So I'm not sure where this discussion is going in the sense that, oh, we're going to test something, we're going to get the performance, and now this is the performance, and we're all going to achieve it. If you don't attach cost to it, I'm not sure where this is going.
Yeah, just to add a little bit. So I think the simple answer to your question is money. So I'm a vendor, and I am developing a system, and I take it to a test house. If for some reason my data gets out there and I don't perform as better than or as good as vendor B and C, I'm not going to win any deals. Back to the RFI, and I'm going to lose money. So there is sensitivity. Cable Labs, for those who don't know, of course, been around for a long time, and has been more on the fixed infrastructure business. And we're a nonprofit, and basically we run the vendor community for the cable industry. And the point I'm making is that they bring their products to Cable Labs. We do validation, conformance, performance, et cetera, testing to the entire ecosystem. Members who are the operators know the performance, to get back to what Ian was saying, but we don't tell the other vendors what vendor B's performance was. So there has to be a couple of different levels of that obscurity, if you will, to make sure that we protect them, but the members know. And the members need to know, what the performance is. So it's a little bit of a different level. But at the end of the day, vendor A and B, we need them to be a part of the ecosystem. And if they're always competing against each other and they're being secretive about it because they don't want each other to know their data, you're not going to develop an ecosystem. So you have to have some level of secrecy.
Thank you. So unfortunately, we're running over time. So one last question, and we use it to give also our closing thoughts.
Thank you to the panelists for having such a good discussion. My question is more related to the scope of the testing, right? I mean, the first round of testing is the labs, but to make this thing prime time ready, there has to be other kind of testing that needs to happen, like field testing, right? And to be honest, it is difficult, from the same family, getting siblings agree which restaurant to go for dinner is difficult, right? How to get the vendors and operators agree for the field test, gather the results. So do you guys see any challenges there?
Yeah, absolutely. And I hate to give you the same answer I've given a couple other times today, money. It takes a lot to deploy networks, and unless the money's available, vendors can't just say, okay, I'm going to go deploy 500 sites to do a field test, because number one, they can't get permits to do it. Number two, they don't have spectrum to do it. So it has to come from somewhere. So at the end of the day, I agree with you 100%. We need to go and take that next step. How do we do that is the question, and the answer is we need to find the funding to do it.
Conway,
just a quick note, there are at scale field deployed infrastructures for folks to try out things in as part of the power program. Feel free to check out.
Any other closing thoughts?
Yeah, I thought that, you know, until we got into performance in the last couple of minutes, I mean, when we were talking about testing, we're talking about like functional testing. That if you give it this input, does it give this output? You know, and we have certain number of vectors, and we say, okay, at least at that level, this function works. I think if you're getting into performance, it's going to be very different, and you're certainly not going to do field performance. I mean, it's very hard for you know to recreate the exact same conditions in field performance.
Yep. But I do want to say that doesn't mean we shouldn't do it. I mean, in fact, people do that, and it's important, right? Because at the end of the day, field performance is the real deal, right? It's really what users will experience, and I think it is important to kind of tie all that back. And in fact, going back to the performance testing, the field testing is one avenue where you can actually also get a sense of, you know, if there's a lot of guarding in terms of performance in the lab, at least in the field, you have no choice. You're going to have to support people in the field. And so OpenSignal is an example, right? There's actually data out there, and you could, of course, do a bit more extraction to understand, you know, what vendors are part of that. But it's one way to get that data is actually through the field.
And you need mature solutions.
Yeah, we've had a couple of opportunities to do that, and I think it's a very important aspect. I think it'll come next, but there's also a big intertwining between field testing, bringing back some of those parameters back into the lab and figuring out what's happening in the lab and taking it back to the field. So we've had a couple of opportunities there, but as other gentlemen pointed out here, there needs to be further opportunities where people are starting to at least get parts of the spectrum to go and try this out. Our project is one of them, clearly, and we've seen a couple of other greenfield where we've been able to play with that a bit. But I think it's an important aspect. Agree.
Thanks. All right. So I think we had a lot of interesting participation from the audience, good questions, good comments from the panelists. So I would like to thank you all. Now there's lunch. And I think, what time do we need to be back? Florian decides, or Irfan decides. 1:40? 1:40 back here. All right.